Hi, this is a video basically describing procedural like workflow pipeline for dailies as well as rendering through the command line, right? And the purpose of this is so that we can like streamline a process. So when in the film industry, we have to run dailies, and for our dailies for effects artists, we just don't show like our one sim and be like, what do you think of it? What we do is we have multiple sims at varying parameters. Most of the time, it's like one parameter change per daily. So we'd have like four different simulations for like particle separation for water or like velocity smoothing. Um, that way, when our clients or our supervisors can take a look at our multiple sims, like the extremes and then two in the middle, uh, they could say what they like about the sims and which parameters they like more than others. So we need a way to get all that. And normally, what we would have to do is we would have to go to like a mantra node or something, and we'd be like, all right, render to disk. We'd have to click that button, and we'd have to do that four times with four separate parameters. And that gets kind of weird because if we let this happen overnight, no one's going to be there to press the render to disk button, and then we also have to compile the images when they're done. And we kind of need like a way that we can have all this stuff lined up, and we just have this button pressed for us, right? And that's where the command line comes in, because what we can do is we can write a Hython script to press that button for us without even having to open Houdini, which is cool for render farms as well. Okay, so just to show what we're going to be working with, I have this little scene that I'm working on where it's just a car takes a turn a little too sharp and rolls off into a little lake. And I started doing this low res simulation right here. Uh, I already have this pre-cached. This is a much smaller scale simulation, and overnight I want a higher res simulation so I can show to my supervisors, right? And just to show it in motion, it kind of looks something like this, right? It comes in and splashes, right? But let's say I kind of don't like how it's not really splashing up over here, and I think that's a cause of friction, right? So we can work with those parameters in a second, but just to show how the setup is set, all we need to do here is we know that normally we would just have a null out to our geometry, right? We do a fluid compress into that null, and this is what here. This is the cache that we're going to be saving, right? So what we do is we go here, and this is the setup that I have made already. But just to go through the process here, we're going to take a geometry node, and we're going to locate that null that we made. A trick is if we just go here, we just Control C that null, and we go to that geometry rock. You can Control V, and it gets that path for us. And then we just say where we want the cache saved to. So it can be anywhere you need. So in this case, I'll call this car 19. Car 19. And frame range to whatever you need, right? So now that we have our cache saved out, we want to do a flipbook, right? And normally we can go down here and like get a quick flipbook, but we kind of want like actual rendered images in a flipbook sense. So what we can, all this is just taking the viewport and rendering it out per frame, right? But it's using OpenGL. So we can also just use an OpenGL renderer and plug that into here, and it works the same way as like a mantra node, except it's flip settings, right? So here we just say what camera we want. It's camera 1. The scene path, we just want everything rendered, because why wouldn't we, right? Yeah, we got the road, car, and the water, and yeah. So we really don't have to change anything here. We can go back to change frame range 1 to 200, and cool. And since we have our display flags set to this we don't want to set this out for dailies. Actually, that's a mistake, because what it's going to do is it's going to cache all the stuff out. Then it's going to go back to this node to render, which is going to have to resim anyway. But what's the point of caching if if we can't even read it? So we should have it set to the render node, right? So we just have which is also brings me to another point. This file node right here is reading an old simulation. So even though we cached a new one, it's reading the old one. So what we should do is we should take our geometry and take that output file and give a relative reference to that geometry, right? And you're gonna have an error because it's obviously not cached yet. but it's going to cache and it's going to be there when it comes down to render. So that's all we need for the OpenGL. And actually what we do need to do is change the output, because what this is the interactive preview, but we don't want an interactive preview. We want to save to our disk, right? So here we can just again write it to wherever you want. So in here I'll say car19 and save it out as a JPEG. And that's really the hard stuff. We can do this shell to generate an MP4, but that's a kind of a different thing, because what we do is we use an external software called FFMPEG. It's literally spelled FFMPEG, and I can put this link in the description. No, not a link. This script in the description. But what you need to do is probably go somewhere else on the internet to find out how to download it. It's just a process, and that's really not what we're here for. You can do this all on your own here with these two. This is just for a convenience thing. But that's the heavy lifting for this. And then also what we're going to need is a batch in between these nodes. And a batch just basically says, like, for batch scripting, it's just a necessary thing, right? And then we just can do a null. Whoops, sorry, a null at the end. And that null just gives us that render button. And now when we render in the out network, if we render the bottom node, it's going to start from top to bottom like a normal Houdini script. So it's going to save the cache first, then it's going to render it out. But if we just hit this button, it does all of them, right? So let's write that to the dailies. And now all we need to do is just to save multiple files for each of our parameter changes. So like in this case, if I wanted to go here and change that friction setting to, sorry, where is it? Okay, sorry, it wasn't a friction setting, it's stick on collision. So like, let's say I wanted to try the different sticks. I can go here and be like, I want this to be 01. And I'll save this file out as car20. And then change this parameter back to 0.2 or something. Then I'll save this one as 21. So each file that we save is going to have different parameters, but they're all going to be cached out and saved sequentially. So now that we have our parameters set up on our files, we can start writing the script so we can have the command line read it, because right now there's no way to communicate with the command line to render the scene. So what we do is we're going to make a batch file, and that requires us to do a little bit of a Hython script in the notepad. So since we're running Hython, we have to declare that we are using Hython, so we just start with Hython. And what we're doing is we're running the hrender, which is like Hython rendering. We're going to be running the hrender Python code. So what we have to do first is say where it's located. And for all basic installations of Houdini, it's all routed to the same place. So it's in your programs files under side effects software. And this is where it changes, but it's in Houdini. I'm running 18.0.287. The only thing that changes is what version of Houdini you're running, and we just have to change that number. And then it should be in your bin folder, bin, and the code, or the Python script is called hrender.py. So now that it's running this hrender, we have to give it its arguments. So we have to say what hip file we're using, and I saved it as car_20 car20.hip.lc. And the other stuff we need is the different types of arguments for hrender. So that's, do we want to say a frame range? Do we want to say a specific ROP file, ROP node to render out? Do we want output for like every frame that we finish and stuff like that? So the basic ones that we're gonna do is -d, and that's us saying what ROP we want to render. And for this case, we are just going to say OpenGL2, OpenGL2, and -v, -e, -f, and our frame range. So our frames go from 1 to 200. Now, you guys are probably thinking like, why didn't we just do dailies 1? Because that's the end of the line. But the reason we're not doing that is because we have a frame range. And if we look at dailies 1, there's no frame range input. So if we wanted to, we could just get rid of this and just like wipe it out and it'll render fine. But this is going to be a template for you later on. So for this case, we can just stick with OpenGL2 saying that we're going to render from 1 to 200. And it'll just be easier for right now if we just did it like that. So we're going to keep it as \d OpenGL2 v to give us an output when we render in the command line. I'll show you what that means when you do it. -e for saying that we want to render a sequence, and -f saying that we want to show, we want to define what sequence of frames. So yeah, we got that, and this is only rendering for car 20, but we also had car 21. So all we have to do for that is just duplicate it and change the HIP file to render 21. So yeah, now that we're done with that, we can save. And the only thing that you have to make sure is, you can write this wherever you want, but we have to make sure is that it's a .batch file. So I'm going to just call this car, I'll say 01 underscore gl.bat. I already did this already, but I'll just overwrite it. So make sure it's a .bat file. You have to say .bat or else it'll default to txt, and no one will know what that means. Right, so we'll replace, cool. And that's it. So at this point, we would have the render farm on whatever computer it's rendering, read that batch file, or we can just do it on this computer here. So you would think that we'd normally just do it through the command prompt, but the thing is that there's Houdini variables that has no idea what they are. So like if we go here, alias and variables, it has no idea what any of these are through the normal command line. We have to use Houdini's command line, and that gives us all the variables and environments that we need. So we just type command lines in our search, and it's defaulted downloaded to our Houdini, so it's cool. If you have Houdini, then you should have it. So all we have to do is just route where our file is located. So for people who don't have command line experience, we have to say where our file is located. So we know that it's in my D drive, water effects, and car01gl. So we just have to navigate this directory, because right now it thinks that it's in the C user's desktop. That's not what we want. So to change the drives, we have to just say the drive letter and then a colon. And now we change the directory. So we say cd water fx. So now we can see here that it thinks it's inside this folder. So now all we have to do is just say car01gl.bat, press enter, and we can see that it's reading the file. It's only the first line though of code. You see it's only doing 21, and you see it's reading the geometry 2 right now. So right now it's caching out. It's going to do one frame at a time. It's going to keep going, and then once that's done, it's going to say OpenGL2 render. And once that's done, it'll say it's closed, and then you'll see this line of code will come up again, but instead of car 20, it'll be car 21, which means it went on to the next file, and we'd keep going. So I stopped the renders because there was no reason to recache everything for me at the moment. It would just take too long. So these this is what you should be getting, is a whole JPEG sequences, and we can see that there's different the names of the files are different, which means it's doing its multiple takes, and so that's cool. We didn't run the FFMPEG, so they're not actual videos. They're just this photo sequence, but it doesn't matter, because what we're going to do is we're going to composite them together and have that quad view kind of look. So we can do that in a Houdini file. We don't have to go into like Adobe's like Premiere or something. We can just do that all in here, and what we can do is we can make a cop network. And what we're going to do is we're going to import our files, And since we're going to do 4, we're going to do 1, 2, 3, and 4. And if we're to just add them together, just like A over B type stuff, they're going to completely overlay each other, right? So we kind of have to say we want this quadrant to be one, this quadrant to be another, this quadrant, and then this quadrant. So we have to scale and then move them into location. So we can do that with transforms, and scales, boop, 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 and scales. Sorry, this looks messy. We can clean it up in a second. Just getting the stuff ready. Right, so cool. And then something like that. All right, so if we go, actually, we can go into the composite view. And this is what our screen looks like right now. How do I go to full screen? What the heck? What the heck? One row, one column. Thank you. Sorry. So yeah, what we're gonna do is we're gonna take this and we're gonna say to resolution. Or we could try this. It doesn't matter. We just have to scale them to 1/4 of its size normally. Okay, actually, let's try it to resolution. So whatever 1920 by 1080 divided by 2 is, so 1920, let's take out a calculator. 1920 divided by 2, 960. 960 by 1080 divided by 2, 540. Cool. 540. Awesome. And now we can transform this guy to the bottom left. Okay, sorry. So the problem why it's not really looking too well is two things. One, we didn't put in our footage, so it's kind of like thinking it's a square right now. And secondly, it doesn't know what the resolution is defaulted. So right now it's just 512 by 512. So what we can do is we can just add a background here. We'll just make that black. But we will set the scale to a resolution of 1920 by 1080. So now if we do an add, let's say we add that on top of that, we see the values 1920 by 1080. So now we can just keep overlaying on top of each other and get the things that we need, get the size that we need. So here we should put in our files, our videos. Yeah, sorry, this takes a while when it defaults to desktop. I don't know why. So, come on. Ooh. Cool, so we can go to the D, and I had it set to water effects, flip, car, and these are all mine that I did. So we can say we'll work with the frictions that I had before, so 15 to 18, so we can do 15, copy that, paste it there, and change it to 18. Oh, sorry, 16. What was I doing? 16. Paste here. 17. And here, 18. Cool. So now we have our stuff set. Now we can just move these to what we needed before. So 960 by 540. 960 by 540. And 960 by 540. Okay, so now that we got the scale set, so they're all in here, we have to change the position of them. So what we can do is we want to start with this one on the top left, so it's going to go 15, 16, 17, then 18. So this one's going to be up here, and so that's just up in the 1, or 1 in the Y. And then this one is going to be on the top right, so we say 1 to the right, 1 up top. This one doesn't have to move because it's right here. And then this last one is going to be 1 to the right. So we can see that it's moving, but it's not actually visible. And that's because the way we're adding on top of each other is wrong. So we want this on top of this. So this has to be on the right. This has to be on the left. Same with this one. This has to be on the right, or the left. This has to be on the right. And swap these as well. So now we have our composite view of all of our stuff, right? It's looking awesome. So now all we need to do is just add a null to the end and label this out. And now we have our stuff. So if we play through, we have our simulations going. All right, awesome. Now, all that's left is to render this out. Now we could also do this gen MP4 again to make it into a movie, but again, you guys would have to figure out how to install that on your own. But we could just go here and gen dailies. We could write another script for this, another command line thing, but this really isn't that intensive. It takes like a minute to do. So all we do is just make a composite ROP network or composite ROP node, and just say what cop you want. So here we just made this one, and that out path was that end, and then just write where you want it saved to. So again, you can just go to your flip and just label it car daily, and then the date, and that's it. You just hit render, and you're good to go. So yeah, you should be getting something like this, and it looks awesome. This is how most people do it in professionally. It's just something that's you don't really want downtime on your computers when you're working. Every moment counts. So anytime we can get as much iterations done as possible, the better. So we can. It's really good to get 4 simulations out in one night. That's really impressive. And a lot of times, we don't know if we want to go high res or medium res. So we can test that through this situation, and like instead of doing the friction like we had set, we can change the particle separation, which is the literal amount of points in your sim, so we can modify that and stuff. So yeah, this is about it for it. Scripting for Houdini, you could do it for anything. You could do it for sims, you could do it for rendering like we did here. You could do the same thing with Mantra, anything that you need. Okay, so I'm pretty bad at the outros, so I just wanted to say thank you for everyone watching, and this information was one that I personally paid for from Rebelway. Amazing class taught by Mr. Igor Zanik, who is an amazing guy. But for respect to Rebelway and Mr. Zanik, I left some key things out, but for the most part, this is the pipeline on how people do it professionally. For some reason, it's not talked about too often, and I don't really know why. Maybe because it's too boring. But this is some professional stuff that people do a lot in the industry. So hope you guys learn from it. Hope you guys do this pretty often. And yeah, thank you. I will be active in the comments, so if anyone has any questions, be free to talk about it. But again, I have to have limits on to what I can answer. So yeah, thank you. See you soon.